Welcome back to the OGSR Library VR Geology Developer Diary. This is video 2, where we're going to be talking about raycasting and interacting with objects. I'll throw it over to Nineveh to walk us through the process.
All right, so we're going to use the scene that we created in our first video to create a laser pointer that projects from our right hand. And when you click the hand trigger on the right touch controller, a post will be placed in that location. So that's going to be our local global positioning location pinpointing. We will also display the world coordinates of our pinpoint location on a canvas inside the scene. So a couple of housekeeping items before we start. Make sure that you have the Text Mesh Pro objects imported into your project. So the regular text objects that Unity provides don't really render well inside the headset, so we're going to use the Text Mesh Pro objects instead. As well, make sure you have the Visual Studio Code editor installed and ready to go to code scripts for Unity. So inside the Oculus integration package, it comes with a helpful prefab called UI helpers. This object contains a laser pointer object, so that's the line renderer and the associated script. So the line renderer is basically just a visual of our laser, a sphere object, which is like a pointer at the end of our laser, and an event system object with the OVR input module script. Under the laser pointer object, we're going to enable the line renderer, and we're missing a material for our laser, so we're going to create one right now. So just right click and we're going to create a new material. I'm going to set it to be an Oculus unlit material. That just shows up better in the headset, and I set our laser to be a white color. You can make it any color that you'd like. We just made ours white. So we're going to set the material in the line renderer. And this is just the visual of our laser object in the game. This is what's going to be extending out from our hand. You can see it right there in the scene. Okay, and we need to make one little change to the laser pointer script that Oculus provides for us. So above the line that declares the variable private laser beam behavior, we're going to add the serialized field line of code. So this is going to make this variable available to us in the inspector window. And if it reloads, you'll see that you can see the laser beam behavior in the inspector window. So we're going to set to the laser beam behavior field to on when hit target. So this basically means that the laser will only be visible when it's hitting the objects or UI that we set it to be activated by. Okay, so click the sphere object, and we're going to set it to the same material as the laser pointer. So it's just a little like pointer object at the end of the laser, just so it shows up like a little rounded edge. It's just kind of a stylistic thing. So under the event system object, we're going to set the ray transform to the right hand anchor. So this is going to tell the code where to place our laser, and we want it to come from our right hand. We're also going to set the cursor to the laser pointer object if it's not already done so. And for the joypad click button, we're going to set it to be the secondary hand trigger. So this is basically telling the code when you want the laser to click on an object, which button you want it to be triggered by, and we want it to be triggered by the hand trigger on the right hand controller. Under the OVR camera rig in OVR player controller, we need to add the OVR physics raycaster script from the integration package. So this script contains an event mask property which specifies the objects that the ray will intersect. So we will create a new Unity layer for our objects that we want to be detected by our laser, and we're going to call that grabbables. Layers in Unity are used to create groups of objects that share the same characteristics. For example, that is, all the objects in the grabbables layer will be detected by our ray. And for the event mask property, we're going to set it to the grabbables layer and the UI layers. They'll show up as mixed in your inspector window. We then need to change the layer on which our Precambrian layer exists on. So we're going to set it to the grabbables layer because we want our ray to cast onto the ground and give us a location. So now we're going to add the rest of our game objects that we need for the scene. We're going to have a canvas with a panel and a TextMesh Pro U GUI object, and those are all tagged accordingly so we can access them in the script. So tags in Unity are used to identify specific game objects in the scene, and we'll be using them in our code a little bit later on. And canvases are already set to the UI layer, so we don't need to change the layer on that one. So I brought in a couple of prefabs or pre-made game objects that I created myself. We have a canvas object, which you can find in the primitive game objects that Unity provides. And I tag the canvas object with, you could just create any tag you'd like. I made mine raycast canvas. And then I just brought in a cube object that I elongated to look like a wooden post. So I just elongated the length and added a wood material. So that's going to act as our little pin when we raycast onto the location. All right, so we're going to bring in our two game objects, so our canvas and our post, to make sure they're in the scene. You can just see my little post object there. So we also need to tag the layer that we have, so our Precambrian layers. Tags are found right beside the layer property in the inspector window, and they're just used by Unity to identify specific game objects, so you can access those tags whenever you'd like in code. So it's a pretty useful tool. So I'm just adding a tag for that right now. And we're going to set it. Also, one more note about the canvas. Make sure that you replace the graphics raycaster with the OVR raycaster script. That I already added that in my prefab to begin with, so when I just brought it in, it was already set. But any UI elements or objects that you want to be detected by the laser pointer must have the OVR raycaster script attached. So for 3D objects like the Precambrian layer, as long as the layer is included in the OVR physics raycaster event mask, then the laser will detect the object. So the OVR raycaster script is mainly used for UI elements. And we're just going to set the pointer in that to be our laser pointer that's in the scene. I'm importing in a couple of scripts that I created for the scene. In our case, when we were working with the Oculus Quest and the integration package, the laser pointer in UI helpers doesn't really come with a hit detection feature in its classes. So we created our own custom laser script to detect hits and to deal with the events that happen after a click action. So I'm just importing them in now, and I'll have Kira describe them for you.
So we have one script to handle the laser hit detection, and then the other one will be to spawn our post at the hit location and show the hit point coordinates on the canvas.
Okay, so I'm adding these scripts to the scene right now, and we'll have Kira explain them after. So create an empty game object, now it's called the input manager, and put our custom laser pointer code. For the hand transform, we're going to make sure it matches the ray transform that we set in our event system from UI helpers, so the right hand anchor transform. And we're going to create another empty game object to hold our other script, detect laser on layer. And that should be it for setting up the scene.
So our first script here is our custom laser pointer script. So here we have a short helper class for our laser, which will handle the hit detection. And this is a singleton class since we only need one instance of the laser at any time. So we'll start by declaring some variables for the class at the top there. So we have an instance of the class, the transform component of our laser pointer hand, which we already set to right hand anchor in the inspector. And then we will also need a raycast hit to store the hit data of our most recent collision. And we will instantiate the class in the awake function, since this is only called once when the script instance is being loaded. And then in our laser hit function, we will create a new raycast, which follows the laser's line renderer and saves the hit data in the raycast hit variable we created above. And the raycast will return true if it was successful. And then we will check that the tag of the collider hit by the raycast matches with the tag of the object we wanted it to hit, in this case, the layer. And so the function will return true if both of these conditions are met and false otherwise. And then we also created a helper function getHit to return the hit of the most recent collision, which was saved in the laser hit function. Okay, so our next script is called detect laser on layer, and this will detect laser hits in the scene using our custom laser pointer functions. It will spawn new post objects at the raycast hit points, and then it will print the coordinates of those objects to the canvas object. So we first need to make sure we're using unityengine.ui to work with any UI objects in the scene. And then we will set some variables in this script. So we need the layer game object, the canvas where we will output our hit point, the text objects on the canvas, a float value to store the data for the button press on the controller, and then we will also need our post object, which we will spawn at our raycast point. So first of all, in the start function, we're going to set the variables for the objects we need from our scene, so the layer, post, canvas, and canvas text by finding their tags. And we will also enable the canvas object so that it's visible in the scene. In the update function, which is called once per frame, we will always be looking for input from the primary hand trigger button on the right controller, since this is the only button we want to trigger our laser. But you can set this to be whatever button you would like your laser to be detected by. And then hand right will store a float value from 0 to 1. 0 if the button is not pressed, and 1 if it is pressed all the way down. So if we register any value over 0.9, we will call the laser hit function in our custom laser pointer instance. And if the function returns true, meaning that the layer was hit, we will call our pinpoint location function. In the pinpoint location function, we first include a time delay. And this is important to include because our update function is called every frame. So if the user holds down the trigger button for longer than 1 frame, it will be registering more than 1 raycast hit per button click and spawning more objects than we want. So we delay the call of this function to be at least every 0.5 seconds to account for this. So next we will get the raycast hit detected in our custom laser script with the getHit function. We will instantiate a new post game object based on the one we have in the scene, which will maintain all of its properties. And we set the parent of the post transform, which holds its position data, to be equal to the layers transform. And this will ensure we can locate the post position locally relative to the layer instead of globally relative to the scene. Next, we will set the position of the post to be equal to that of the raycast hit point, which will allow it to spawn in the hit location. We do this by accessing the point component of the hit, which returns a vector3 coordinate value of its position. Now we can visualize with the post exactly where we clicked on the layer. So we can now print the coordinates of the raycast locations. We can do this both through the console with debug.log and onto the canvas by setting the text component of the text object. So once we have these scripts, we will be able to see how this all works in the scene.
So then we can just build our scene as normal and display our scene inside the headset. So you can see in our scene, the white line represents our laser. And when I click the hand trigger on the right-hand controller, it places a post in that location on the layer, and you can see that the canvas updates with that local location from the layer.
The location information we're getting is the vector3, right? Which is how you can use it as the origin of the post, and we can use that for other calculations later, right?
Yep.
So in video 1, we brought in 3D models and explored how to move about them in the headset. In video 2, we explored raycasting and how to find the coordinates of a specific location and how to spawn an element there. And then in video 3, we're going to use some of our database that we have at the library to figure out what sort of oil, gas, or water features are near that location and spawn some data that relates to that. So we're going to be using the raycast combined with the database search to spawn some relevant elements on the map, depending on which resource we're looking for.